So the last lesson we're going to do in this unit is we're not doing 5.8. 5.8 is actually a grade 10 topic, but we'll save it time. Okay. There's really nothing new here. We're going back to those 3 exponent laws we learned back in unit 4. Like if you multiply 2 powers with the same base, remember what you did with the exponents. If you multiply, what do you do with the exponents? Add them. If you divide 2 powers with the same base, x and x, subtract. If you take 1 power to another, you multiply. We're going to do the same thing, except remember in unit 4, the bases were all numbers. Here, the bases are all going to be letters. So it's going to be things like this. What's Sure. Yeah, this would be x to the 5. Add the exponents. This would be a to the 9th divide a to the 5th. A to the 4th. Base stays the same, subtract the exponents. If we did z to the 3rd and raise that to the 4th, z to the 12th, multiply. So it's the same thing. We've learned these, okay? But we're going to make them a little bit more complicated than this. So this one, first example, remember, this is the same as a squared times b to the 7th times a to the 3rd times b to the 5th. Whenever I'm multiplying a whole bunch of things, the order that I multiply doesn't matter. So I could switch it and say, okay, I'm going to put the a's beside each other. And then I'm going to put the b's beside each other. And what's a to the 2nd times a to the 3rd? Add the exponents, a to the 5th. What's b to the 7th times b to the 5th?
A to the 12, or b to the 12.
B to the 12th. And then I can't multiply those 2 into a single power, so I just leave it like that. We don't have to show all this work. I'm just showing you how we can do it. So for the second one, think of it this way. Multiply the coefficients, the numbers in front by each other, multiply the t's, and then put those together. So if I multiply the numbers in front, what do I get? -7 times -3. Okay. Anybody think it's different than t to the 4th?
Oh, is it because t to the 4th?
Well, I got 4 t's being multiplied here, right, by each other? How many are there? So t to the 4th times t to the 1st is t to the 5th, right? If you see a variable, a letter without an exponent, put a little 1 there to remind yourself. For C, multiply the numbers. What do you get? Two numbers. 2 times -5. Here's 10. Multiply the powers of x. X to the 6th times x squared. Careful. When we multiply, what do we do with the exponents? Add them. So it's x to the 8th. And then it would be y to the 5th. Good. That's it. Now this one is a little interesting. How many multiplications do you have to do here? Aren't I taking this and multiplying by everything inside? So don't I have to do 3 multiplications? Remember, your exponent, what exponent goes with the x? We just don't write it, 1. And 1 goes here. So remind yourself of that. What is 3x to the first times 2x squared?
3x to the 6.
6. What is x to the first times x to the second?
2. X to 3.
X to the third, because we add the exponents.
For the next part, is it 3x to the second?
Yes. So for the next part, it's 3 times 1, which is 3. X to the first times x to the first, add the exponents, we get x squared. And finally, 3x times minus 5. Can I combine any of these? Are they have like terms? Do they have the exact same variables and the exact same exponents? No, so I can't add or subtract them together. I could multiply them by each other, but I can't add or subtract them. So that's as far as I can go. Well, dividing, same idea, except now we're going to subtract the exponents. So what's y to the 7th divide y to the 4th?
Is it y to the third?
Yeah, because we got to subtract the exponents because we're dividing. Times z to the 4th divide z to the 3rd.
Z to the first?
Z to the 1st, or I don't even have to write that little one, do I? I could just leave it as y to the 3rd z. Both would be right. Divide the numbers. Divide the numbers in front. What do you get? Remember, we're not doing 18 minus 3. We're doing 18 divide negative 3. What's 18 divide negative 3? And then m to the 6th divide m to the 3rd is m. Got it. Try the next one on your own. Remember, if it doesn't have an exponent with it, what do we write? A 1. So divide the numbers, then divide the A's, then divide the B's. Sienna, yeah?
Isn't it 9 and then 8 to the 4 and B to the
Perfect, well done. 9A to the 4th, B to the 5th. So you notice that things could get a little bit complicated, ladies. Come on. Like, I could ask you, let me throw down 4 questions here. And you get them all. Some of them are exponent laws, some of them are not. Some of them are just collecting like terms. This is probably the most challenging part of this, is knowing the difference between all of these when we're adding, when we're subtracting, when we're multiplying, when we're dividing. What do you think x squared plus x squared is? Did you say? Jenna, did you say? This one. What's this one? X to the fourth. Anybody got a different answer?
2x squared.
2x squared. Anybody got a different answer? We are not multiplying, so we don't add the exponents. We've got a 1x squared and a 1x squared, which together make 2x squared. That's not an exponent law when we add powers. Divide. It's x to the 0 because we subtract. But what's that the same as? What's anything to the 0? 1. And that makes sense because isn't anything divided by itself just 1? Like 5 divide 5 is 1. -7 divide -7 is 1. X divide X is 1. Smiley face divide smiley face is 1. Doesn't matter what you use. If you divide it by itself, it's always going to be 1. What's this one?
Just x squared.
Oh.
Isn't it -2x?
Oh. Anybody got a different answer?
Wait.
Wait. Bro.
Hey, what did it just like cancel out though?
So what's your answer? Look at you. Look at you. Yeah. It's nothing. Anything subtract itself is nothing. And what's this one? Now everybody's a little hesitant.
X to the 4.
X to the 4. It's a multiplication, so we add the exponents. So you see, you got to know the difference between them. And like I said, it can get a little complicated sometimes. You know, and it goes back to this one up here. Where we did exponent laws, but then we can't collect like terms because these aren't identical. Okay? Finally, the third exponent law, which basically you call power to a power. When we have power right beside power, exponent right beside an exponent. When they're right beside each other, what do we do? Multiply. So I get a to the 20. Here's where you got to be careful. These next two. What do you think this would be? Almost. You did the p's right. But remember, isn't this, don't I have to do 3 to the 3rd times p to the 5th to the 3rd? I have to cube, I have to raise everything inside to the 3rd. So what's 3 to the 3rd power? That's a number. 3 to the 3rd.
3 to the
27.
27.
That's right. That's what you got to be careful of, is when there's a number in here. Because you have to raise that number to the exponent before you do the variables. So here, you've got to think of this like, okay, I'm doing -2 to the 4th. Then I'm going to do x to the 3rd to the 4th. Then I'm going to do y to the 3rd to the 4th. And what is -2 in parentheses? That's important to the fourth. Positive 16. Times x to the 12 times y to the 12. Okay? What's that? Oh, careful, don't all jump in at once. Negative x in the third, yes. 2 minus 3 is -1. It's not an exponent law. What's that?
Is it 8 x to the 9? Wait. I'm trying to do reason.
6. 6 is 2 times 3. What do we do with the exponents when we multiply? Add them. We don't multiply the exponents. We only multiply them when they're right beside each other. So we add 3 plus 3. Yeah. Now, if you combine your two answers, you guys were right. Oh, here's one. What x to the third did you say?
1.
1? You got the x to the third. But what's 3 divided 2?
It's none of this.
Yeah, it's a decimal. We can't divide it cleanly. Remember what I said? Don't touch that calculator. Remember what I said. If you can't divide it cleanly, leave it as a fraction. You can't divide it cleanly, so leave it. 3 over 2 is 3/2. 2 over 3 is 2/3. 4 over 5 is 4/5. You don't need that calculator. It's all good. Oh.
It would be, wait. Would it be 16 x through 1 to 9? 12 x to all these little things. No, because then no. That's right. Yeah, so it's x is 16, is it not? No, it's not 4. X, the
2 to the 3 is 8.
x to the 6.
Good. Okay, so these are the ones that we got to practice with. We want you guys to be really good with these, really comfortable with these, because it's like I said, with algebra, a lot of this stuff we're doing right now, okay, you want to be really comfortable with it as we move into grade 10, 11, 12. Because the quicker you can pick it up and the more thorough you know it, it'll make those later grades so much easier, trust me. Don't want to delete.